The title of my is Integrated Science Assessment, but what I was asked to talk about was EPA's review of the particulate matter science, this is the U.S. EPA, and the conclusions we've drawn over the past decades. And so I'll just briefly highlight. Oh, okay. And this is supposed to. It doesn't. Just briefly highlight what our conclusions most recently, and go into a little, just for the audience, the next slide is the NAAQS process. And National Ambient Air Quality Standards are set under the Clean Air Act. There's a few slides added at the end for people who aren't already familiar with this. There's a few slides added at the end in supplementary material, but the Clean Air Act requires us to identify common, many-source ubiquitous pollutants, and there are 6 of those. Particulate matter is one of them. We set standards for them, and the Clean Air Act recognizes that science is constantly building and evolving, so it requires us to review the standards every 5 years. So as part of that process, we plan. The Integrated Science Assessment is highlighted in yellow, so that's the part the Office of Research and Development does, and that then supports policy assessments, risk and exposure assessments. Zach Picard is going to talk a little bit about that later this afternoon. And then all of this builds to support regulatory decisions about whether the standards are adequately protecting health and the environment. And this is an ongoing process. We finish one set of standards as we did for PM in 2006, and we start all over again. The next slide just briefly highlights what an integrated science assessment is. And it began its life as an air quality criteria document. We've changed the name, we've changed the process a little bit in the last few years. The basic pieces of the review of the standards remains the same, the review of the science and the policy and risk assessments. But the Integrated Science Assessment is intended to provide the scientific basis for the review of the standards. It evaluates and integrates evidence from scientific disciplines across the health effects side, toxicology, controlled human exposure studies, epidemiology, and also in ecological and environmental effects. The Integrated Science Assessment we've recently completed has conclusions and causal judgments for both health and ecological effects. It includes fine particles, coarse particles, ultrafine particles to the extent possible. For this one, I note at the bottom, for this particular symposium, I'm focusing on the effects of fine particles. But we have conclusions about other types of particles and other types of effects in the Integrated Science Assessment. Real briefly, the next slide shows the causal framework that we have developed in the past few years. We've always drawn causal conclusions, but actually Dr. Samet has been at the front end of driving us to use more consistent terminology, more of a standard approach to how we draw these conclusions so that we don't use scattershot language, which happens in many cases. So for all of our reviews now, we determine whether or not we believe there's causal relationships between the pollutant and a health outcome or an ecological outcome in these 5 categories, with causal, of course, being the highest and not causal at the lowest. The next slide I won't even read over. It shows an example. We won't spend any time on it, but just shows an example of the language that's used for this, so that we have some sort of standard language so that as we're drawing these, we look to our language to make sure that we're building on these. And let's not spend any more time on that slide. Let's move to the next one. But that's just an example, and all of our integrated science assessments include that table, and all of our decisions are drawn in that framework. This shows, just to highlight that this is not new to this review. We've drawn conclusions in previous reviews, including the last 2 reviews. In 1997, stepping back for a minute, there's a slide at the back of the presentation that shows the history of the reviews. We established PM standards in 1971 based on total suspended particulate matter. And we've continued to review those standards as we've gone through. In 1997, we added standards for fine particles, or PM2.5. At that point, based on the evidence that Mr. Greenbaum just went through, there were quite a few new epidemiologic studies, and we usually don't count studies, but in this case I remember there were only 9 studies that actually measured fine particles, but there's a lot of evidence from toxicological studies of components of fine particles, little experimental evidence on the mechanisms for particles as the mixture. But the basic conclusion at that time was likely causal, so it's the second down causal determination of ambient PM. In this case, the determination was made on particles as a whole. The studies ranged from fine particles to TSP. In the next review that we just completed a couple of years ago, there were hundreds of epidemiologic studies, so the body has grown, quite a few using PM2.5 directly, and a greatly expanded body on experimental evidence that shows mode of action of the particles themselves. At that point, we drew a conclusion that was likely causal relationship between PM2.5 and a broad range of effects, mortality and morbidity, sort of grouped together. So we've drawn these conclusions of essentially likely causal over the last couple of reviews. We haven't actually used our structured, nice language, but so it's not always consistent in how we characterize it. But we've drawn conclusions that particulate matter is associated with health effects for the past few reviews. In the current review that we're underway, if you move to the next one, we just completed an integrated science assessment last year. The review of the standards is underway, and it's anticipated that we'll have a final decision on whether to retain the current standards or change them in 2011. The integrated science assessment now, the evidence is continuing to build. Now there are hundreds of epidemiologic studies, many including both PM2.5 and the coarse fraction particles. There's a greatly expanded body of evidence, experimental evidence, that indicate mode of action, especially for cardiovascular effects. And there's a growing body of evidence on the constituents of particles, which is something that is of great interest, of the different sources of particles. And the next two slides summarize. So the first one is our causal determinations for PM2.5. And here in this case, we determined that the relationships were causal for cardiovascular effects and mortality, likely causal for respiratory effects, and it was difficult to determine for central nervous system effects. So this growing body of evidence has now drawn a conclusion of causal. And when I say cardiovascular effects, that includes cardiovascular mortality. There are a lot of studies that look at mortality. Many of them look at mortality altogether, all-cause non-accidental mortality. But cardiovascular mortality, of course, is at the most severe end of the spectrum of effects for cardiovascular effects. So the next slide